If you've ever tried gel nails, you'll know you have to bake your hands under a UV lamp. And if you're like me, you might have thought, I know UV from the sun is bad and causes skin cancer, tanning beds are extra bad, extra skin cancer. Is this thing that looks like a tanning bed
for ants
actually safe? We are getting to the bottom of this today. I'm Michelle of Lab Muffin Beauty Science, chemistry PhD, ex-nail art enthusiast, I used to have skills, and skincare/sunscreen nerd. Let's get into it. First, a quick rerun of UV. UV is a type of light. It is higher energy than visible light, which is this stuff. We mostly get it from the sun. It is the part of sunlight that causes skin cancer, sunburn, premature aging, and uneven pigment. With the dangers of UV, we need to think about two things. The first thing is wavelength. Sunlight has two big categories of UV. UVA has longer wavelengths and UVB has shorter ones. We are going to think of these as tiny balls called photons. UVB's photons have higher energy, they smash into things harder, but they don't get quite as deep into skin. UVA's photons are lower energy, they cause less direct damage. So which one is going to be more damaging? That is not a trick question, it is UVB. It's like getting punched. UVB is like a really hard punch with more energy. UVA is less hard, less energy. Both of them contribute to skin cancer and premature skin aging, but with different amounts and in different ways. And within each category, there is still going to be a range. Some UVA is high energy and it is almost UVB. It has more UVB-ish effects like sunburn, but then some UVA is lower energy and it is basically just purple light. The other big thing that matters is dose. This is how much UV your hands are getting, which depends on how much UV the lamp is producing and how long your hands are in there. If you've seen my videos before, you'll know I say the dose makes the poison a lot. That is important for ingredient safety, but also for UV safety. One punch might not do much, but then 1,000 punches is going to be really different. And that is the same with UV hitting your skin. More means you have more damage. So what wavelengths and doses are we actually getting here? Well, we need to talk about why we have UV in the first place. It is how gel polish works, and this is really cool and clever. Regular nail polish has polymers in it. These are long chains, and as the polish dries, they come together and turn into a solid layer on your nails. But at some point, nail scientists realize if you create the polymers on your nails, you put those little diamond building blocks onto the nail, and then you join them up afterwards, it ends up lasting a lot longer. There are three main categories of these longer lasting products: acrylics, gels, and dips. Here are some of the most common building blocks in gel polishes. They have double bonds which are in pink, and that means a chain reaction can join them together. This is like a row of dominoes falling. When the first building block gets triggered, this bond can basically move to join up to another block. This triggers block 2, its bond moves to join to block 3, and so on. You get a long chain, which is the polymer. It's a chain reaction that actually makes a chain. Eh? But the tricky thing is, how do you make sure the building blocks don't join up too early in the bottle and turn into just like one giant clump, but they do join up after you put it on your nails? The answer is different for acrylics and gels and dips, but for gels, the answer is UV. As well as the building blocks, the gel polish contains initiators, and these are ingredients like one of these. They break up when they hit by UV and they turn into little triggering molecules. They are actually free radicals. They attack a building block and start off the chain reaction, sort of like your finger pushing over the first domino. So that's why we need a UV lamp for gels to break up the initiators which set off this polymerization reaction. I wrote a book called The Science of Beauty that talks a bit more about how gels and other nail systems work, as well as about 100 other topics on skin, hair, nails, makeup, and just beauty products in general. You can check out the link in the description or this QR code. But with this UV gel situation, the problem is different gel products have different mixtures of building blocks and initiators. They will activate with different wavelengths and doses of UV. The combination of all of these things are carefully optimized so that it reacts at the right speed, because if it reacts too quickly, it can give off too much heat, which firstly hurts, and it can also cause your nails to separate from the nail bed, which is really painful and gross. But on the other hand, if it reacts too slowly, it might not cure completely, and that is also a bad outcome. Foreshadowing. Plus, in both cases, the stuff that's on your nails is less optimal, it will crack and come off faster, so that is why you are meant to use the specific lamp for a specific gel product, and that is why there are so many different nail lamps. Gel polishes really took off around 2010, and that is when people started really wondering how safe these little tanning bed looking things are. So there are now quite a few studies measuring the wavelengths and doses of UV that your hands get in a whole bunch of different lamps. Some of these studies were done by nail scientists, so there is a conflict of interest, but the most comprehensive one was done by academic scientists who don't have any ties to the nail industry. There are also scientists with a long track record of sun protection research and measuring UV. Some of these were done by dermatologists, and one was done by a panzer, who is where I got these cute magnet and key rings from at a conference recently. There's one that's like slap on a hat and one which is slap on some sunscreen. Oh, they're great. So what do these studies say? Back to our two big things, which were wavelength and dose. With wavelength, there are two main types of nail lamps. There are UV lamps, which have fluorescent bulbs. They look like this, kind of tube-ish. And then there are LED lamps. They have LED bulbs. They are a bit newer and they have like little flat dots or squares inside them. Both of these produce UV, even though it kind of sounds like LED lamps don't. I would like to know who picked these names. I just want to talk. I'm going to call them fluorescent and LED because that would actually make sense. And to make it more confusing, because that is really what we need more of, some lamps have both fluorescent and LED bulbs, and I'm going to call them combo lamps. Fluorescent bulbs tend to produce a wider range of wavelengths. They mostly give UVA, but also a tiny bit of UVB. LED bulbs produce a narrow range of wavelengths and they are mostly longer, so pretty much just UVA and visible light. Here is a graph from one of the studies. The higher the hump, the more of that wavelength you are getting. There is nothing in the UVB region. Well, there is actually something if you expand it a whole bunch, which these researchers did in a different graph. It is a bit hard to see what's going on, but the three fluorescent lamps have their biggest hump at about 370 nanometers. The three LED lamps have bigger humps, but they are at about 400 nanometers, so they are putting out kind of half UVA and half visible. Now let's lay a dose on top. With UVB, all of the studies found that there isn't that much, which is reassuring because that is the one that smashes right into DNA. It is more directly linked to cancer. The study that tested the most lamps, and it is more recent, so it's tested newer lamps, found that there was close to no UVB for almost all of the lamps they tested. Each of these dots is a lamp, and all of these dots are really close to the bottom, which means less UVB. All of the lamps produce way less UVB than you would get from the sun in winter. But UVA is a different story. UVA knocks electrons off things to form free radicals, which is exactly what we want in a gel polish, but that can also happen in your skin, and that will cause chain reactions which will mess stuff up. It's less bad than UVB, but it does still contribute to skin cancer and accelerated skin aging. Again, each of these dots is one UVA lamp, and the higher the dot, the more intense the UVA. This line shows the UVA from midday winter sun in Barcelona. This line shows the UVA from midday summer sun, and about a third of the lamps are higher. Some of these lamps actually produce more than twice as much light as the summer sun, and these are the ones above this new green line. You might have noticed that the dots look different. The blue solid squares are the fluorescent lamps, the crosses are combo lamps, and the square outlines are LED lamps. So LED lamps do seem to be a safer option in terms of total UV, and that is probably because they mostly produce longer wavelength light, which is less energetic to begin with. They also produce a lot of visible light, which is the bottom chart. You can see how these square outlines are way higher. So at this point you might be thinking, well, we have the perfect solution, don't we? I get less UV with LED lamps, so I just have to look for these knobbly dotty lights. I thought this too, but unfortunately this is not necessarily the case. There is a newer study, which is the Alpanza one. They looked at 7 LED and 1 fluorescent lamp, and if you put them on the same chart, they look like this, assuming that they measured them roughly the same. LED can actually get really high. And this brings me to a little tangent about one really crucial thing when it comes to interpreting beauty science studies, and this took me a little while to learn. There is this general vibe that a conflict of interest automatically means that a study is bad, but there is actually a really big downside to a lot of studies by independent researchers who have no conflicts of interest. They're often not designed well, or they might not be interpreted well because the researchers didn't really understand the area well enough. This is because a lot of cosmetic science isn't actually in the peer-reviewed literature because there is just not that much incentive to publish there. I talked about this in my video about retinol. There also isn't that much funding, so you get a lot of tiny sample sizes, and once you've read enough cosmetic science studies, this trend is like right up in your face. I've talked about bad studies from independent scientists before, like rosemary oil and hair loss, chemical sunscreens killing coral, zinc oxide inactivating chemical sunscreens, and a whole bunch of tranexamic acid studies. And this comes into play here. Two of the studies by dermatologists actually used the wrong type of spectrometer, which is an instrument for measuring light. Two of the really experienced sun exposure scientists actually point this out in their papers. They work in a light testing lab that tests UV lamps, and they also have patents on UVA lamps for medical treatment, so there is a conflict of interest. But really interestingly, this mistake actually meant the dermatologists were underestimating UV, so these scientists' results were going against their conflict of interest. This isn't a blanket rule. The newest two studies didn't have conflicts of interest, and they used the right type of spectrometer, from what I can tell anyway, as a chemist who has used spectrometers, but I really don't specialize in them. One study has authors from the official Australian Radiation Agency, and the other one sent their lamps to an accredited lab, so they are probably reliable. And of course, there are bad studies by researchers who do have conflicts of interest, like the valuable benzene ones that I've talked about before. Basically, there are no general rules when it comes to conflicts of interest and how sus a study is, especially when it's an area that just doesn't have that much public funding like cosmetic science. Anyway, back to lamps and cancer, we have a bunch of lamps that are putting out more UVA than the summer sun. And while super intense UVA over decades could potentially be bad in ways that we just don't really know yet, the evidence really points to this not being a massive issue. First off, we don't put our hands in these for very long, maybe 10 minutes every few weeks, so the total UVA energy that you're getting every few weeks is maybe 20 minutes of midday summer sun, and that is not including the most damaging part of that sun, which is the UVB. But it's actually even safer than that because your skin reacts to specific wavelengths in different ways. So first off, remember we still have a range of UVA, we have harder and softer punches, but it gets a little bit more complicated than that. So back to our punching analogy, one hard punch might break your nose, but if you have two punches that are half as hard, that might not break your nose even though the total energy of both are the same. Longer, lower energy wavelengths are generally much less harmful, and that is exactly what our nail lamps have. So some studies have tried to estimate this with something called an action spectrum. Basically, they are weighting the wavelengths based on how much damage they cause. So for example, this spectrum, 300 nanometers will give you about 1,000 times more damage than 350 nanometers. Here are some of the different risks that have been calculated, and you can see they are all pretty low. So we have less skin reddening UV than the same amount of time, say 10 minutes in the winter midday sun. There's also a non-melanoma skin cancer risk, which is a bunch of times less than sunlight. It would take hours to get to the maximum allowed time for tanning beds. Sunlight is almost twice as carcinogenic. You would get one extra case of cancer in more than 44,000 people who were all getting 40 years of regular manicures with an older lamp. And on top of that, the backs of your hands are less sensitive to UV. One study actually measured that they take about 4 times more UV to burn than your cheek. Now, there are a few case reports of skin cancer after getting lots of gel manicures, but the manicures didn't necessarily cause the cancer. These aren't really scientific evidence, they are just meant to be a way for doctors to flag interesting cases that might inspire future research. It is like a form of anecdotal evidence, but really nicely written up. And in most of these, there was some sort of extra factor involved. So for example, this person was taking a photosensitizing medication, as well as getting UV manicures for 10 years. This person had been getting manicures for 18 years and also using a tanning bed every week. And a lot of their exposure was also probably from the older fluorescent lamps that put out more UVB, and the types of skin cancer they got are more associated with those shorter wavelengths. Now, what about skin aging? One study looked at skin sagging and elastosis, which is when UV messes up the elastin proteins that are in your deeper skin, and that causes deep wrinkles and texture. Elastosis is worse with shorter wavelengths, but UVA at 340 nanometers is actually the worst for sagging, so higher here means worse. Back to these charts, this is what it looks like compared to summer and winter midday sun. Most lamps are less than summer sun, but then a handful are higher, but the highest is still only about double. Now again, you might be thinking at this point, if I just go for the LED lamps, I'm only getting the longest wavelength, the least damaging UVA. You can see how low these outline squares are. And again, sadly, this is not our easy solution. I originally thought it was because in all of the older studies, they just had a peak at about 400 nanometers, which is really close to the visible range, hence why these squares are so low. But again, it is our sloppy, slappy Australian study. And this is tucked away in the supporting information. They have these graphs and they found that 5 out of 7 of the LED lamps are putting out shorter wavelength UVA at about 370 nanometers, and that is the main peak for the fluorescent lamps in the older studies. Those older studies looked at salon lamps, this one looked at home lamps, but I would guess that some of the salon LED lamps are sort of like this now as well. I mentioned non-melanoma skin cancer before, so you might be thinking, well, what about melanoma? Isn't that more linked to UVA? Well, there aren't actually any case reports of melanoma with nail lamps, so none of the studies really focused on that. Plus, linking UV wavelengths to melanoma is a lot more complex. But this study looked at population level or epidemiological data from the US, and they found that there has been no increase in melanoma and actually a slight decrease in younger people. The locations of the melanomas aren't tracked, but this does suggest that so far, this isn't a big problem. So this is all pretty reassuring, but there are some really simple things you can do to lower your risk even more if you get gel regularly and you are worried. You can put gloves on without fingertips to cover up your skin. You can also put sunscreen on your hands before the gel manicure and then just clean the sunscreen off your nails. Also, don't look at the lamp while it's on, that is not good for your eyes. If you're taking medications that increase your light sensitivity, or if you've already had skin cancers, then don't do that. Also, make sure you check your hands for suspicious spots, especially if they are changing over time, and see a specialist once you notice them. You don't need to worry much about your nail beds. Nails actually block all UVB and almost all UVA, and once you have the gel on top, then that drops even more. You should still check for spots though, because there can be cancers under there that aren't linked to UV. Now, every once in a while, you do see nail lamps and skin cancer pop up on the news and social media, and the last few times, it was a scary sounding study like this one that came out in 2023. These are the headlines that it caused. This was an in vitro study, which means cells on plates that look like this were placed inside a nail lamp. The scary part is the scientists found mutations that are linked to skin cancers, but this is what we call a hazard experiment. It shows changes that could happen. It doesn't actually show what is likely to happen, which is the risk. This is because they're not taking dose into account. The cells are actually getting much higher doses than normal. Inside our skin, the living cells are under a whole bunch of dead layers that block a lot of the UV, and cells don't exactly behave the same in our skin versus on a plate. Plus, this experiment exposed the cells for 20 minutes continuously and then 20 minutes again on the same day, which is way longer than a typical manicure. They also don't really consider how many mutations the cells got. And some of these limitations were mentioned in the study, but they didn't really reference the newer lamp measurements. Also, that is not how the authors were talking about the results in the media. They're saying things like, it is very alarming. They personally do not get gel manicures anymore. Some journalists did ask other scientists to comment, and they gave much more context. We do already know the hazards of UVA. 5 minutes of Australian summer sun without sunscreen would give you much more mutations. They also mentioned the other studies which show low risk and also some tips to make us safer. Sorry, I just have to quickly mention, I actually met Professor David Whiteman recently at that sun protection conference with the cool swag. He actually invited me to speak there, and he also talked about sunscreen myths at our Beauty Cycle myth busting camp. I will link that below. I have been coming across his research for a really long time, and he is just like the nicest guy. It was just a massive fangirl moment. On to the actual scary risk with gel manicures that the foreshadowing was all about. This is allergies. I know allergies sound kind of minor, but they can be a really big deal, especially with the ones we're talking about here. When I'm using a gel or a dip product, I do sometimes stop and go, well, maybe I should be a little bit more careful right now. It is not the UV I am ever worried about, it is the allergies. Acrylics, gels, and dips all use acrylate monomers as their building blocks. After it's cured and they are joined up, the final polymer chain is big, so it doesn't actually get into your skin that easily, and that is not a problem. The problem is before it's joined up, so when it is still in those little monomers, that is when it can get into your skin, and if you do get exposed enough, you can develop an allergy, and then next time you use them, this kind of thing happens. You have swelling, blisters, itching, rashes, mostly around your nails, but also in places that you might touch with your nails, like your eyelids and your face. And the bigger problem is that acrylates aren't only used for nail products, they are used for lots of things like sticking bones together in orthopedic surgery and a whole bunch of dental materials. So if you do have an allergy, you might end up reacting to a filling or something which is just really not nice. Fun fact, OPI stands for Odontorium Products Incorporated. They actually started as a dental acrylics company before they switched to nail acrylics. How to avoid this? James Welch has a video that goes into this in more detail, but basically, you want to minimize any exposure you have to the gel before it cures. Your nails generally aren't the problem, they are pretty resistant, so you only really need to worry if your nails are cracked or very thin. It is skin that's the issue. You want to make sure you paint inside the lines, you don't want to be as messy as you might be with nail polish. You also really want to cure the polish thoroughly. You need to make sure that you apply thin layers because otherwise the UV might not reach down through all of the gel. You also want to use the matching lamp with your product and follow the curing times. Don't try to use less UV because you are scared of UV. You also want to make sure that your lamp is clean and maintained because things like dust will lower the UV output. You also don't want to touch the sticky layer that's on top of the nail at the end. That stickiness is actually unreactive polymers. And because it is harder to do your own nails neatly, it is probably less risky to go to a properly trained nail tech. There has been a massive rise in these allergies because of home gel kits, especially after lockdown when everyone was doing their nails at home. I was going to rant about how gel polish companies keep saying that they are safer than regular nail polish because they are free from all of those common dirty ingredients. Of course they are, because they don't need those ingredients. They work in a completely different way. And nail polishes are, in my opinion, just way less risky, and they actually have ingredient lists that are easy to find. But I kind of already did that in this video, which is about how dangerous nail polish ingredients actually are. If you want to learn about everything UV and sunscreen, check out this playlist.